All right, let's enjoy logarithms. Example 4, part A. We have an equation here that we're about to solve. Obviously, whenever they say to solve, that would imply that we're solving for the variable, in this case x. And you'll notice on these are the easier kinds to solve because, as we've seen before, when the variable is only in one term, we can use the idea of inverse operations, parentheses, exponents, multiply, divide, add, subtract. We can use that logic to isolate the x. You might recall the discussion was, in that order of operations there, which operation over here is furthest from x? So if we talk it through like we've done before, we would have parentheses, so all these expressions in the those operations in the parentheses would be considered closest to x. Exponents. All right, we're going to talk about this. See, exponents and logarithms are actually related to each other. All right? And so if the question in your mind is, how do you get rid of a logarithm? Well, we'll remind you here in a moment, that's the inverse, basically, of an exponent. So, parentheses, exponents and logarithms. Multiply would be the 5. How about the subtract 9 would be the furthest operation from x. So again, once we identify the operation that's furthest from the variable, in this case subtraction, we would introduce its inverse operation, addition. So the equation then transforms into 5 times the log base 2 of 4x minus 3 equals 93. All right. And continuing on, what's the furthest operation at this point from x? Parentheses, exponents and logarithms, multiply, multiplying by 5. So I believe you would instruct me to divide both sides by 5. Again, the inverse operation of multiply is divide. And so at this point, the equation becomes log base 2 of 4x minus 3 equals, I believe that is 18.6. All right. Continuing up the ladder here. See, this is how we use inverse operations to solve equations, as we've seen before. I would hope you would concur at this point. We have parentheses, and then we have that logarithm outside. And this is where it's my job to remind you, and this is why we spent so much time on examples 1 and 2 talking about how to go back and forth between logarithmic form and exponential form. See, here you go. Here's your connection. Exponents and logarithms are actually inverse operations in this context. And so that's the point where we would say, all right, how do we get rid of a logarithm? What's the inverse of a logarithm? And that would be to change it over to the corresponding exponential. And so this would be that logarithm dance that we practice on examples 1 and 2. You know, this thing to that power equals this thing. And so applying that, changing the logarithmic to an exponential, in this case, we would get 2 to the 18.6 power, 2 to the 18.6 power equals the quantity 4x minus 3. Recall the logarithm dance that we practiced. Go back and review examples 1 and 2, where we went back and forth between exponential and logarithmic. So at this point, we can now put 2 to the 18.6 power in a calculator. 2 raised to the power of 18.6. We've talked about how to do that in previous days. So if you put that in a calculator, that becomes 397,336.0036. I'm out of space here, I'll have to move this. Equals 4x minus 3. All right, that's just putting this in a calculator. And then, of course, you hopefully would know the remaining steps would be to add the 3 at this point, which will give us, I can do that in my head, 397,339.0036 equals 4x, and then of course divide the 4 to finish it out, and we'll have our completed value of x. All right, so doing those 2 remaining steps here, adding the 3 followed by divide by 4. In my experience is once we get to this point, folks do just fine. And it looks like x would be equal to 99,334.7509. So once again, we're fortunate here because the variable is in one term, and so we can use this inverse operation approach to isolate the x. And the new twist on these would be, there will be a point where we need to realize that exponents and logarithms would be considered inverse operations of each other. So let's just keep practicing.